Myself, Mohana Sundari. My project title is Studies on Concrete containing bottom ash as partial replacement of fine aggregate. Have did this under the guidance of external guide Mr. P. Srinivasan ME, Senior Scientist at Advanced Concrete Technology Lab, Structural Engineering Research Center. And my internal guide is Mr. P. Rajesh M. Tech, working as an Assistant Professor at Vail Tech Engineering College. An abstract. This project works aims to study the properties of concrete containing bottom ash as partial replacement of fine aggregate. The bottom ash is obtained from the thermal power plant station. Presently, fly ash is being used as a pozzolanic material in concrete. The bottom ash is a coarse material and does not possess any pozzolanic properties, and it is proposed to replace the fine aggregate up to 40% in concrete. The physical properties and the durability of concrete, such as compressive strength, split tensile strength, and rapid chloride penetration test of different ages were planned. 3 mixes with different water cement ratios and 40% replacement of sand with bottom ash were cast. Introduction. Bottom ash is agglomerated ash particles formed in pulverized coal furnace. Physically, bottom ash is typically grey to black in color, is quite angular and has a porous surface structure. Bottom ash can be used as a replacement for aggregate and is usually sufficiently well graded in size. Objective: to investigate the feasibility and the potential use of washed bottom ash in concreting and concrete applications. To apply the mechanical properties of special concretes with 40% washed bottom ash replaced by weight of normal sand is found to be an optimized use in concrete in order to get a favorable strength and good strength developed patterns over the increment. Scope. This project aimed at meeting the future demand without sacrificing the quality. The physical strength and the durability of the concretes were planned to determine with a higher replacement of bottom ash percentage in future. These are the literature reviews and physical properties test. Color blackish by appearance, specific gravity by pycnometer, and fineness modulus by sieve analysis test. Chemical composition test, extra diffraction. Materials. Cement. Ordinary Portland cement was used for this study, and aggregates. Fine aggregates as normal river sand is considered having a size of not greater than 4.75 mm, and coarse aggregate of size about 20 mm is considered. Binders. Coal bottom ash was obtained from Neyveli Lignite Corporation. Superplasticus. A linium with density as 1.10 and pH value as 5 was used in the study for increase the workability. These are the chemical compositions and mixed designs. The mixed designs is chosen for this study is 1:1.7:3 for achieving M40 grade. Further, the coal bottom ash is used as washed bottom ash. For this study, the replaced coal bottom ash percentage is fixed at 40% by learning formal research in coal bottom ash. For making concrete with washed bottom ash, different water cement ratios in different 0.4 to 0.5 is provided. Test results. The fineness modulus value is 2.82. And these are the results of compressive strength of bottom ash concrete. These are the results of conventional concrete. And flexural strength results. Split tensile strength results. Chloride penetrability based on charge passed. For the first casting, the charge passed range is in between 2000 to 4000, hence the chloride ion penetration is moderate. For the second casting, the charge passed range is in between 1000 to 2000, hence the chloride ion penetration is low. For the third casting, the charge passed is in range between 1000 to 2000, hence the chloride ion penetration is low. Results and discussions. The split tensile strength increases with the decrease of water cement ratios at 28 days for 40% replacement concrete. The flexural strength decreases for 40% replacement with increase of water cement ratios at 28 days. The density of ordnance concrete linears increases in 40% bottom ash replaced concrete compared to control concrete. Workability of concrete decreases with the replacement level of fine aggregate with bottom ash due to the increase of water demand. The addition of bottom ash up to 40% replacement for fine aggregate does not alter the durability property. Hence, it is concluded that the bottom ash can be used as partial replacement of fine aggregate in concrete. Conclusion. For the results obtained, we have concluded that the physical strength and the durability of the concrete does not affected by replacing the bottom ash as fine aggregate in the concrete. Dumping the bottom ash as changes the characteristics of soil, hence the bottom ash can be used as a construction material instead of landfill. These are the references. Thank you.